Do you feel like buying a shovel and digging a 20-foot hole with a 10-foot radius, then placing 675 venomous snakes you just caught in the deepest parts of Australia, then throwing your math textbook into your pit of snakes? Terrific. We can help you avoid getting fined $25,000 for keeping exotic animals by watching this here video by Fort Bend Tutoring and Mr. Witt.
Hello ladies and gentlemen, this is Mr. Witt with Fort Bend Tutoring, and today's tutorial is going to be about verifying trigonometric functions part 3. That's right, this is going to be the third part of a 4-part series on verifying trigonometric functions. That means that we're trying to make the left side equal to the right side, or trying to make the right side equal to the left side, or working them both down to a point to where they equal to one another. Now, my preference is to make the left side equal to the right side, so that's the way I'll be doing these problems in today's video. How about that? And I got 8 problems for you, starting out with number 1. Here we have cosine squared x minus 1 divided by cosine x equals negative tan x times sine x. Alright, so the first thing I want to do when tackling verifying trigonometric functions is I want to be able to either change everything in the cosine or sine functions, or be able to identify a trigonometric property that will allow me to break the problem down into what I want, which is the right side. So what I notice in the numerator here is a reference to a Pythagorean identity that we have. So I'm going to start by doing the following. I'm going to factor out a negative in the numerator. Yeah, it's going to look like this. I'll have a negative parentheses 1 minus cosine squared x in the numerator all over cosine x. That's what I have thus far. And now I'm able to show that this 1 minus cosine squared x can be substituted with sine squared x, which is exactly what I'm about to write. So I'll have a negative sine squared x. That means that I'm replacing the 1 minus cosine squared x using that Pythagorean identity with the sine squared x. And of course that negative just came down, and this is going to still be over my cosine x, just like that. Alright, from here I'll be expanding this fraction and writing it as negative sine x over cosine x times sine x, alright, over 1. Just like that. Now remember, what we wanted from the beginning was to make the left side equal to the right side, and the right side has negative tan x times sine x. So what I recognize is what I have thus far is almost what I need. So I'll be using that quotient identity, that tangent identity, to know that sine x divided by cosine x is tan x. So that means that I can bring down the negative, and that sine x divided by cosine x is tan x. Okay? And because I'm multiplying times sine x over 1, I can just bring that down as sine x, just like that. Well, now the left side now equals to the right side because we're done. We just verified it. It's over. Okay? So now we're moving on to problem number 2. So let's move on. Alright, problem number 2, ladies and gentlemen, we have 1 divided by 1 minus cosine x plus 1 divided by 1 plus cosine x. And this is supposed to equal to 2 cosecant squared x. So what we'll be doing in this problem is, first of all, getting a common denominator. That's right. So what I notice is that I have 2 rational expressions, aka fractions, and I can combine those once I get a common denominator. And what would that common denominator be, you say? Yeah, it's going to be the 1 minus cosine x times 1 plus cosine x. So I'm going to go ahead and start by setting up my framework here. And here we go. And so my LCD will be 1 minus cosine x times 1 plus cosine x. All right. And that's what I'm going to have for the denominator for both fractions. All right. So this is what it looks like thus far. Okay. So whatever I had to multiply my original denominator by is what I'll need to multiply the numerator by. So notice that I only had 1 in the numerator originally, but I did multiply that denominator by 1 plus cosine x. So I need to have 1 plus cosine x here in the numerator, just like that. Okay, and then in this second denominator we had 1 plus cosine x, and we multiply that by 1 minus cosine x, and 1 times 1 minus cosine x is 1 minus cosine x. Alright, so now that I have common denominators, alright, and equivalent fractions for that matter, I'm going to combine my numerators together. Yeah, That's what I'm going to do. So I'll be able to rewrite this as 1 plus cosine x plus 1 minus cosine x all over my common denominator, which is 1 minus cosine x times 1 plus cosine x. Yeah. Okay, then what happens in the numerator? We have additive inverses. That's right. We have cosine x, a positive one, and a negative cosine x. Well, these will cancel out here. And the last time I checked, 1 plus 1 is still 2. So this is going to be 2 over, and I'm going to go ahead and distribute these two binomials right here. I know you've been waiting on it. I know you've been waiting on it. Yeah, this binomial times that binomial. I'm going to get my arrows popping here, okay? If you don't mind, get my arrows popping. So I end up with 1 times 1, which is 1. And then 1 times cosine x is a positive cosine x. It sure is. Then I'll have negative cosine x times 1, which is a negative cosine x. All right, and then we have negative cosine x times cosine x. That's going to give me a negative cosine squared x. All right, so this is what I have thus far, just like that. Okay, so in the denominator, what happens is, once again, we have additive inverses. We can cancel these out, and now I can rewrite this rational expression as 2 over 1 minus cosine squared x. All right, just like that. And it turns out, ladies and gentlemen, using that Pythagorean identity, that 1 minus cosine squared x is equivalent to sine squared x. Okay, so now we have 2 over sine squared x. And so now I'll be expanding this to show that this is 2 times 1 over sine squared x. And using your reciprocal identity, 1 over sine squared x is cosecant squared x. So that means that this simplifies into 2 cosecant squared x, which is exactly what the right side was, and we're done with problem number 2. Done and done, ladies and gentlemen. So let's move on to our next problem. In problem number 3, we have secant x plus 1 divided by tan x, and this is supposed to equal to sine x divided by 1 minus cosine x. So what I'm going to do first of all is I'm going to change everything into cosine and sine functions. That's what I'm going to do. So I'm going to rewrite the secant x in the numerator as 1 over cosine x, and that's using that reciprocal identity. This is going to be plus 1, and then in the denominator with that tan x, well, using your quotient identity, tan x is equivalent to sine x divided by cosine x. Just like that. Now, we really don't want to have complex fractions within this problem, right? So we can get rid of all of those by multiplying every single element here by cosine x. Yeah, I'm going to multiply the numerator and the denominator by cosine x, all right? I'll be distributing that, which means I'm going to get my arrows popping, ladies and gentlemen, okay? Love the distributive property. So 1 over cosine x times cosine x is just 1. Then 1 times cosine x is cosine x, all right? And then in the denominator, multiplying cosine x times sine x over cosine x, yeah, the cosine x's will cancel out, leave you with sine x in the denominator, like so. That's what we have. So knowing that I have this now, I'm going to now use the conjugate of the numerator. And what lets me know that I need to do this? Let me go ahead and show you. Look at the denominator of the right side. It's 1 minus cosine x. That's my clue. So knowing that they have the conjugate of my numerator in the denominator, yeah, that's a little suspect. Yeah, I'm not buying it. We're going to go ahead and multiply the numerator and the denominator now by the conjugate of the numerator, which is 1 minus cosine x. Oh, yeah. All right. So here you have it, ladies and gentlemen, another technique when verifying trigonometric identities, and that is multiplying by the conjugate. And in order to find the conjugate of a binomial, all you have to do is change the sign on that second term there. And that's exactly what I'm doing. Okay. So once I have this, ladies and gentlemen, what I'll be doing from here is multiplying all of this out. Yeah. So if you multiply 1 plus cosine x times 1 minus cosine x, yeah, which means that you can go ahead and foil those binomials together, or if you prefer, you can call it distributing, like I do. Then you'll end up with 1 minus cosine squared x. All right, and then in the denominator, what we'll do is we'll just show that this sine x is multiplying on that binomial 1 minus cosine x. All right, so I have now sine x times 1 minus cosine x. All right, just like that. Okay, so we only distributed in the numerators here. I pretty much left the denominator alone. I just used a simplified form of showing that we'll be multiplying sine x times the binomial 1 minus cosine x, all right? And you'll see why. All right, and now using substitution, we know that 1 minus cosine squared x, using that Pythagorean identity, it's going to be equivalent to sine squared x. Yeah, and this is currently over this sine x times 1 minus cosine x. All right, so this is what we have thus far. And now I get an opportunity to simplify. Because I have sine squared x in the numerator over sine x. See, one of these sine x's will cancel out here. It's going to cancel out, yeah. Because that exponent of 2 over that exponent of 1, 2 minus 1 leaves me with 1 in the numerator. It leaves me with 1 in the numerator. So I'll end up with sine x all over this 1 minus cosine x, which is the right side. So that completes problem number 3. Done and done, ladies and gentlemen. That's problem number 3. All right, on problem number 4, we have cosine x divided by 1 plus sine x plus cosine x divided by 1 minus sine x equals 2 secant x. All right, so the way I'll attack this problem, ladies and gentlemen, is I'm going to start out by recognizing that, okay, I have 2 fractions on the left side of the equal sign, and I want to make that into the right side. And on the right side, I only got 1 term. I only have 1 term on the right side. So what does that mean? That means I need to add these 2 fractions together. And in order to add these 2 fractions together, I need to get a common denominator. And that common denominator, yeah, it's going to be 1 plus sine x times 1 minus sine x. So I'm going to go ahead and show that in this first step. All right, so I'm going to set up my framework here, just like so. And I'm going to have a common denominator that's 1 plus sine x times 1 minus sine x. And that's what I'm going to set up right here. 1 plus sine x times 1 minus sine x. All right, and I need that in both denominators. Let's make sure that's in the screen there. So we have that 1 plus sine x, and then multiplying that with 1 minus sine x. All right, so there we have it. That's my common denominator. I'll be multiplying the numerator by what I had to multiply that original denominator by, okay? So we had to multiply the first denominator by 1 minus sine x. So I need to multiply cosine x times 1 minus sine x. We have to get equivalent fractions here, all right? Act like you know. You know we got to get equivalent fractions, so this ain't nothing new. Then in the second denominator, we had 1 minus sine x already in the denominator, and now we have the common denominator, so we ended up multiplying by 1 plus sine x. That's what we'll need to multiply this new numerator by. All right, so you'll have cosine x times 1 plus sine x. All right, just like that. Now that we have a common denominator, we'll be able to combine our numerators together. So what that means is that I'll be distributing now. That's right. I'll be getting my arrows popping over here, okay? So I'll get my arrows popping in both numerators, and I'm going to combine those numerators together, all right? Well, my arrows showing for you. There you go. There you go. There you go. So I'm rewriting our combined numerator now, and that's going to be cosine x times 1, which is cosine x. And then cosine x times negative sine x, that's going to be negative cosine x sine x. All right, just like that. Then cosine x times 1 is cosine x. It sure is. It sure is. And then finally, I have cosine x times sine x. That's going to give me a positive cosine x sine x. All right, just like that. That's in the numerator. And then what I'll do for you in the denominator, yeah, I'm going to go ahead and multiply that common denominator out. That 1 plus sine x times 1 minus sine x. So just to show you, hey, it's 1 times 1. That's going to be 1. Then 1 times negative sine x is negative sine x. Yeah, we're just foiling this out. Sine x times 1 is sine x. That's a positive. Sine x, thank you. And then sine x times negative sine x, that's going to give me a negative sine squared x, like so. From here, you should recognize that what we have now in the numerator are additive inverses. We have opposites. In other words, we can cancel out that cosine sine x. Yeah, I have a negative and a positive version of that term. They cancel out to 0. Thank you. And in the numerator, what we have left, we have cosine x plus cosine x. That gives me 2 cosine x. So in the numerator, I now have 2 cosine x all over, And check this out. My sine x's, they cancel out. Once again, we had additive inverses. So you're left in the denominator with just 1 minus sine squared x. All right, so that's what we have thus far. Now that I have this, note that 1 minus sine squared x is just your Pythagorean identity rewritten. In other words, this 1 minus sine squared x, that's equivalent to cosine squared x. So I can rewrite this as 2 cosine x all over cosine squared x. All right, so now that I have this, we can now simplify, right? Because you have cosine x in the numerator, whereas you have cosine squared x in the denominator. So that means we can simplify this by cosine x. So cosine x goes into itself once, and then cosine x goes into cosine squared x, cosine x times. In other words, I can cancel out one of those cosine x's in the denominator. So we're now left with 2 over cosine x. And this can be rewritten and expanded to show that this is the same thing as 2 times 1 over cosine x. Okay, and if you're familiar with your reciprocal identities, you should know that that 1 over cosine x is secant x. Thank you. So multiplying those results together, you'll end up with 2 secant x, which is exactly what we wanted. Left side now equals to the right side. And done. That was your problem number 4, ladies and gentlemen. We will now be moving on to the next problem, which is number 5. Here it is. Here it is. Getting it in view just for you. So now we have in problem number 5, 1 minus 3 cosine x minus 4 cosine squared x divided by sine squared x, and this is supposed to equal 1 minus 4 cosine x divided by 1 minus cosine x. Well, whether or not you choose to use substitution or not, what you have in the numerator, yeah, that's a quadratic trinomial. It surely is. So for instance, let's say I substituted cosine x for, let's say, the variable m, as in Mary, that this would be rewritten as 1 minus 3m minus 4m squared, which is a factorable quadratic trinomial. So using that principle, using that concept, I can go ahead and factor this into its result, which will be 1 minus 4 cosine x times 1 plus cosine x. Just like that. And then in the denominator, that sine squared x, yeah, using my Pythagorean identity, I'm going to show that that sine squared x is equivalent to 1 minus cosine squared x. There you go. Notice how often we use the Pythagorean identities. Just saying, you may want to keep those in mind. From here, I'll be factoring the denominator. Yeah, see, if I factor that denominator, that 1 minus cosine squared x, which is a difference of squares, I would end up with the same numerator, that 1 minus 4 cosine x times the 1 plus cosine x. All that remains the same. However, in the denominator, that difference of 2 squares, this will end up giving me 1 plus cosine x times 1 minus cosine x. All right? So there you have it. This is my breakdown. This is the factorization of the numerator and the denominator. Amen. So what are we going to do now? We're going to recognize that we have the same factor in the numerator and the denominator. That 1 plus cosine x over the 1 plus cosine x is 1, so it cancels out. Bye. Goodbye. You're gone now. And you know what? Once that's gone, what you end up with is 1 minus 4 cosine x all over 1 minus cosine x, which is the right side. That completes that problem, ladies and gentlemen. That was problem number 5 and done. All right. Problem number 6. For problem number 6 here, we have 1 divided by tan theta plus tan theta, which should equal secant theta times cosecant theta. All right. What I propose we do is change everything into sine and cosine functions. Yeah. So I'm going to rewrite this as 1 over sine theta divided by cosine theta. That's using that quotient identity. Same thing occurs here with that tan theta. Same thing. I'm going to rewrite this as sine theta over cosine theta. There it is. There it is. From here, I can rewrite that first complex fraction as a division problem. So I'm going to show that this is equivalent to 1 divided by sine theta, all over cosine theta, yeah, plus that existing sine theta over cosine theta. All right, so this is what I have thus far. All right, and this, by the way, is a division symbol. I'm going to now show that when dividing fractions, we end up multiplying by the reciprocal of the second fraction here. So this is equivalent to 1 times cosine theta divided by sine theta. Yeah, just like that. And this is going to be plus sine theta over cosine theta. See, we haven't changed that second fraction since the beginning. We haven't changed it. So now that I have this, ladies and gentlemen, we can just multiply that straight across. You know that 1 times anything is itself. You know this already. So that means that I just have this cosine theta over sine theta, okay, plus sine theta over cosine theta. And once I have this, I'm going to get a common denominator. Okay, so setting up my framework. All right, I need to get a common denominator between sine theta and cosine theta. Well, that's just going to be cosine theta sine theta. All right, just multiply them together. So I'm going to put the cosine theta first. All right, you'll see why in a second. You'll see why in a second. All right. So now that I have my common denominator in play, notice that whatever I had to multiply the original denominator by, okay, I have to also multiply the numerator by. And we had to multiply that original sine theta in order to get our common denominator times cosine theta. And so cosine theta times cosine theta gives me cosine squared theta. It sure does. And I had to multiply the original denominator here, that cosine theta times sine theta. So multiply that times our numerator to get an equivalent fraction. You'll end up with sine squared theta. Okay? So this is what we have thus far. Let's get it in view. Let's get it in view. All right. All right, so continuing on, now that I have a common denominator, we're going to go ahead and combine these numerators together. So I now have cosine squared theta plus sine squared theta all over my common denominator, which is cosine theta sine theta, just like that. And you should know, because of your Pythagorean identity, that cosine squared theta plus sine squared theta is equal to 1. So this is now 1 over cosine theta sine theta, just like that. In fact, we can expand this into the following form. We'll have 1 over cosine theta times 1 over sine theta, just like that. Yeah. And you should know your reciprocal identities, right? That 1 divided by cosine theta is secant theta, right? And that 1 divided by sine theta is cosecant theta. Exactly. Once you have that, ladies and gentlemen, the left side has just become the right side. We're done with problem number 6. All right, in problem number 7, we have cotangent squared x minus cosine squared x equals cotangent squared x times sine squared x of pi over 2 minus x. What you see, ladies and gentlemen, on that right side here, that especially with that sine squared of pi over 2 minus x, that should remind you of a cofunction identity. So I'm warning you that that's what we'll be using in this problem, a cofunction identity. So let's begin by converting everything, ladies and gentlemen, into cosine and sine functions. All right, and I know that cotangent squared x can be rewritten as cosine squared x over sine squared x. Absolutely. And you know what? I'm going to get a little fancy here. I'm going to show that this cosine squared x is over 1. Yeah, that's what I'm going to do. And at this point, I'm going to show that I will eventually get a common denominator by multiplying this second fraction here by sine squared x over sine squared x. All right, once you multiply that out, you'll end up with a common denominator that will combine to give you cosine squared x minus cosine squared x times sine squared x. And all of this is going to be over sine squared x, just like that. From here, ladies and gentlemen, what we'll do is factor out cosine squared x from those two terms in the numerator. So I'm going to factor out my cosine squared x. That's going to leave me with 1 minus sine squared x in the parentheses here, which is over sine squared x. Absolutely. From here, you can now show that that cosine squared x over sine squared x using your quotient identity is equivalent to cotangent squared x, right? And the 1 minus sine squared x using your Pythagorean identity is equivalent to cosine squared x. All right, this thing is starting to come together here. Now we'll be implementing that co-function identity, which states that if you have cosine squared x, it has to be equivalent to sine squared of pi over 2 minus x. Exactly. So now I can fashion this into the right side to look like this. It'll be cotangent squared x times sine squared of pi over 2, all right, minus x. And that is now the right side. Yeah, we're done with problem number 7. And I have one more problem to show you. All right, and here it comes. All right, problem number 8. Check this out. We have problem number 8 with log of 1 minus sine x plus log of 1 plus sine x equals 2 log of cosine x. All right, so we got a little logarithm going on here. So what I'm going to do first and foremost is show that anytime you have the exact same logarithmic base, and you have a sum of that common logarithmic base, you could then rewrite that as multiplication. So that's what I'm going to do. I'm going to show that this is equivalent to log of 1 minus sine x, all right, times 1 plus sine x, just like that. Okay, so this is what I have thus far. Then I'll be multiplying these two binomials here. So I'm going to bring down that log here, and let's go ahead and just get our arrows popping, right? So I'm going to get my arrows popping. Okay, so 1 times 1 is 1. 1 times sine x is sine x. All right, there we go, there you go, there you go. Then negative sine x times 1 gives me a negative sine x. Thank you. And then negative sine x times sine x is negative sine squared x. Yeah, just like that. What happens to your middle terms here inside the parentheses? They cancel. Those are additive inverses. And I end up with log of 1 minus sine squared x. And using our Pythagorean identity, we know that 1 minus sine squared x is equivalent to cosine squared x. So this is now log of cosine squared x. How you like that? Rewriting this, ladies and gentlemen, this is equivalent to log of cosine x squared. And using your logarithmic properties, anytime you have an exponent here, you can go ahead and bring that in front as a coefficient, and we could write our result as 2 log cosine x, and this is now the right side. Done. Yeah. So that, ladies and gentlemen, was verifying trigonometric functions part 3 from me, Mr. Witt, and Fort Bend Tutoring. As always, please rate, comment, and subscribe, and if you're able, please donate, as that helps us bring you more free math tutorials from FBT, Fort Bend Tutoring. Peace.
Thanks for watching. We feel great knowing that you got some help and you're safe and sound. Now, if you'd be so kind as to like this video, subscribe to our YouTube channel, Fort Bend Tutoring, and like us on Facebook, we'd be much obliged.